Students, this is Unit 7, Lesson 7.1, Circle Parts and Central Angles. You're taking a look on this page. Make sure you get a parent or guardian sign-off. Let's start with a quick recap here. We're going to graph a line that y equals negative 3/4 x plus 4 and goes through that point, a line perpendicular to this line. Let's do this one together because it's been a very long time since you've seen this stuff. So first we're just going to graph that given line. We're at positive 4 as our intercept. And then our slope was negative 3/4, so that's down 3 and over 4. It's a negative line. So that's y equals negative 3/4 x plus 4. We want a line that's perpendicular to that line and goes through the point negative 2 and negative 4. So let's carefully graph negative 2 and negative 4. And now we're going to draw a line. First I want you to draw it, and then we're going to check it out. The algebraic way is the most accurate, but I want you to see it from graphing to start with. So from that line, let's go ahead and graph a line perpendicular. You want to use a straight edge here. So that is potentially our line. Let's now check it algebraically. So we want a line that's perpendicular to this. So the perpendicular slope, if this is negative 3/4, our perpendicular slope is 4 over 3. So we have y equals positive 4 over 3x plus an unknown b that we don't know. We're going to stick our negative 2, negative 4 should be here, negative 2 and negative 4. So we have our y is negative 4 4/3. This is negative 2 plus b. Now, most of you can see right off the bat, you're going to end up with fractions here. So I'm going to get rid of the fraction after this next step. So we have negative 4 equals negative 8/3 plus b. We're going to get rid of that fraction. We're going to multiply everything by 3. Make sure you distribute to all 3. We end up with negative 12 equals negative 8. Plus, this is the trick, don't drop that 3 there. We add 8 both sides, and of course that's going to be negative 4 equals 3b. Divide by 3, and b equals negative 4/3, which is negative 1 and 1/3. So your equation is going to be y equals 4/3 x minus 1 and 1/3. Now, if you look closely when you graph that, that means our intercept should have been approximately about right there, which if we graphed it is probably more accurate than what we originally draw. Yours might be. And yes, that is much closer to a right angle. So that's why it's very important that you do this algebraically prior to. Some of you think you can just solve everything by graphing, and you can't, especially when you're dealing with a fraction. So that's just a gentle reminder. You have to be able to do the algebra here, not just graph. Circles. We're going to be talking about circles for the next 20 minutes. We have lots of vocabulary here. Let's just kind of check it off as you read it. Circles, radius, diameter, something called a central angle, minor arc, major arc, a semicircle, concentric, chord, something called a secant, a tangent, and the concept of measure. Most of this vocabulary is going to be right here. You're going to want a straight edge. Step 1, the center of a circle is simply the center of the circle. It is named by a point and a capital letter. So let's just call that B. And when we name circles, we name them by their center. So the symbol here for this circle would be a little baby circle with a dot. Put a dot so you don't mix it up with O. We would call this entire circle, circle B. The actual circle, of course, is the edge itself. Radius. It's like the spoke in a wheel. It's a radius. A diameter goes through, is 2 radii essentially. It goes all the way across, also through the middle. A chord is a segment whose endpoints are on the circle. That would be a chord. So all diameters qualify as a chord, but not all chords are a diameter. Tangent. Warning, that word tangent has absolutely nothing to do with SOHCAHTOA tangent. It's a completely different word, but in English class, you talk about going on a tangent in your discussions. It means to kind of be talking about something, but then go off topic a bit. So physically, a tangent looks like this. You're going to draw a line or a segment that touches a circle at one point. So it just touches the circle at one point. That is called a tangent, either a segment or a line. And of course, that dot would be the point of tangency. A secant is going to come from the outside and go through the circle all the way, and it intersects at 2 points. So a line that goes through the circle and intersects at 2 points, that's a secant. Or it could go through the circle and end. Let's do another one here. Right, just do one right next to it. Here we go. See, it's still intersecting at 2 points. Both of those are secants. Trick to a secant is it starts from the outside and it intersects at 2 points. There's the vocabulary you're going to need for the next 3 weeks. We're going to do this page together because I don't want you making any mistakes here. Name the circle. This would be circle A. Little dot, circle A. A radius, of course, would be the spoke in a wheel, so A to F or A to H, either way. Diameter goes all the way across, so F to H or H to F. A chord. Now watch carefully. I could do DG is a chord. But I'm going to name another one because I want you to see it's also a chord. Watch what I do. CD is also a chord. But then I can come down here to a secant, and BD with the arrows. Notice I've added the arrows. That's a secant. So watch that notation very carefully. A tangent means to touch from the outside, so that's going to be BJ. That's a line. Of course, our point of tangency is H. Now, there's some relationships within circles that you need to be familiar with. if circles intersect each other and intersection points, they intersect. These circles here are tangent, which means they only touch at one point. Tangent, they touch at one point. Concentric, they share the same center exactly, like a target. And of course, congruent, the definition of congruent circles is all they have to do is have congruent radii. Automatically, if you have congruent radii, you have congruent circles. Now there's some terms here, key terms, a minor arc, major arc, semicircle, and a central angle. A minor arc is a piece of the edge of a circle, and we use 2 letters, and it's less than 180. So I'm just going to write a part of the actual circle, and it's going to be less than 180 degrees. So we would write this BC. If we do 2 letters, that implies the distance, this piece right here, which is less than 180. A major arc, again, is a part of a circle. Which is greater than 180. So put your pencil on C and sweep around the long way around the edge. C, D, B. Notice I'm using 3 letters now. You could also go the other way around. That's more than 180. Notice I'm using 3 letters. Semicircle is half a circle, exactly. So it's half of a circle, so it equals 180, of course, degree measure-wise. We also use 3 letters for that, so E, H, G. Arc symbol. That's minor arc, major arc. And then a central angle, you want to think of a central angle as a pizza slice angle. It is connected to the center. So it's an angle, vertex on center. And of course, our example here would be angle BAC because it is circle A. Now there's some properties of central angles, specifically about central angles and their minor arcs, and there's 3 of them. The first and most important is whatever the degree measure of the central angle is, let's say this was 60 degrees, the degree measure of the arc is the same. So we're going to note it like this. The measure of the central angle, BAC, that's a central angle, is going to equal the measure of the minor arc measure, watch. We put a little M means measure, BC, the arc. Okay, you see the little music signs, guys? This is the beginning of a song. Just the first line, I'm going to sing it. It's going to sound weird because it doesn't have resolution yet because it's not the whole song. Goes like this. Measure of a central angle to its arc the same. Measure of a central angle to its arc the same. So when you have that central angle, it's going to equal the arc. Measure of a central angle. This one's really easy. If you have congruent central angles, you have congruent arcs. Congruent central angles, congruent central arcs. And that's simply true because of that first premise, that the angle equals the arc. Last one is simply that adjacent arcs can be added. If you have adjacent arcs, you can add them up. For example, the measure of arc A to D plus D to B measure, we don't add arcs technically, we add their measures, is going to equal the arc measure. It's a semicircle now, so A, D, B. So little arcs add up to big arcs. Now, keeping in mind these three things, we're going to do a problem here, and I'm going to introduce a very simple but very critical concept. In the diagram below, EB is a diameter. Super important. All diameters, trace, stretch, sweep. So I trace EB. I stretch it out, and this is where your straight edge comes in handy, because you want to be accurate here. Stretch it out. Trace, stretch, sweep. Always do that with the minute you have a diameter, always do that. When you do that, you're going to see immediately you got some 180s going on here, and always I would sweep both directions. So that word diameter, trace, stretch, sweep. You're told that the other three segments are radii. The measure of angle FAB is 60. FAB is 60. And the measure of angle, central angle BAC, is 52. Find all possible arcs and angles. You ready? Sing with me. Measure of a central angle to its arc the same. So if that's 60 and that central angle, that arc on the outside is also 60. I want you to mark both. 52, 52. Now let's go ahead and work our diameter here. That's straight. Now we can find EF, which of course is 180 minus that 60. We get 120. Let's see what else we can find here. We have a 90 here, which means this is 90 degrees. Now we can sweep from here to here. Let's add that up. And now we're going to get E to D by doing 180 minus the 142. Do you see how powerful those diameters are? They give you all kinds of information. And of course we get 38 here, and don't forget the central angle here. Whoops, I forgot one central angle right there. Now double check. Do you have all your central angles? Check. Do you have, you just kind of wrap it around, do you have every single arc? Check. That is an example of what you're going to be doing during class time. Alrighty, let's take a look here. I'll do this one with you. Okay, we're going to start by stretching out the diameters. RU, so trace, stretch, sweep. And SV, trace, stretch, sweep. Now watch the notation very carefully. The first thing we're going to find is the angle UQV. So we go U to Q to V. Now find that angle. And you're like, how can I find the angle if I don't have any other information? So watch very carefully. You do have a diameter here. Let's just re-highlight this. From here to here is 180. So you can see to get that angle right there, it's simply going to be 130 away from 180. So watch out for those diameters. They give you lots of information. That's 50. Okay, now we're going to do the arc, RTV. Remember, it's an arc, so it's on the edge of the circle, and we have to go in that exact order, RTV. So R, start at R, stay on the circle. It's really important that you stay physically on the circle, R, go through T, and end at V. That's the arc. Notice it's a major arc. So we're going to find the measure. You can see that we have 180 here, plus 50. So the measure of that arc is 230 degrees. Next one, let's do VRT. Got to go in that exact order, VRT, the arc. So we start at V, and we go through R all the way around to T. So we need all of that orange. Now, one thing you also don't want to overlook, way back at the beginning of the year, we talked about vertical angles. So if that's 50, that's 50. So we're going to walk this around, and you can see that's going to be 130 plus 50. And then if we come around this way, we have 86. And you simply add. So the measure of the arc, VRT, is 266. We'll do this one together. It says stretch out the diameter KH, trace, stretch, sweep, 180, and then JG, trace, stretch, sweep. So we want to solve for X, of course, and then find all the arcs and angles. So we have to start with our numbers right here. We're told that that's 100. Measure of a central angle to its arc the same. So that's 100. Do me a favor, just trace KH and trace again JG. KH, do it again. JG. One more time. KH, trace, JG. Do you feel those are two straight lines? If we got two straight lines, that means we have vertical angles. So if this is 100, oh, wow, look at there. That's also 100. Which means this arc over here is 100. So now we can see we can solve for X. So 9X plus 5 plus 10X equals 100. How did I know that? Okay, because if this is 100, that's 100. Measure of a central angle to its arc its same. That means 9X can also transfer down here. So collect like terms. Just so you can see the math here, let's do 19 times 5 and see what happens. You see that's 95, so X equals 5. But wait, there's more. Let's go ahead and take that value of 5 and plug it in. So 9 times 5, we just found the measure of this angle is 45 degrees. And 10 times 5, that means this is going to be from here 10 times 5 is 50. That's 55, which makes sense because it has to add up to 100. And we take a look, see what else we can do. Remember, we got the 180 here. And we can go like this. That means that's 80 because of the 100. That means this is 80. Vertical angles, that's 80, and that's 80. Make sure you always get the central angle with its corresponding arc. Okay, pause the video here, do your own work, and then restart. One little caveat, keep in mind, these two little marks means those are equal. Find all possible angles, then find the major arcs below. Pause the video, then check your work. Okay, students, welcome back. Let's see if first off, immediately, you should have traced, stretch, and sweep those diameters. You got 180 going this way. And we also have 180 going this way. It's really important you catch that. The angles, 106, we're going to walk it over. 106, which means this is 106 vertical angles, 106. Split in half, that's going to be 53 and 53. 106 take away from 180, this is going to be here 74. 74, let's get those outer arcs, 74, 74, 53, 53, and we just check, we got all our arcs and all our angles. Now, we're going to find the major arc FHD. You have to go in that exact order, FHD. So like this, go around, FHD. That's the red, and that's going to be 53, 74, and 106. $233. Let's try another one. Let's do HDF. HDF. So we go here, H, D to F. You can see this right here is 180 plus 53. You can see here this is 180 plus 53. So we got a 3, a 13. Oh, the same thing. Last one, FDH. So we have to go in that order. F, go through D and H. Notice, it's the exact same measure, just going the different way, which is entirely possible. So if the blue is 233, the green is also 233. Students, it's vital that you just take 2 minutes here, just 2 minutes, set the timer on your phone, and verbally recap what you have learned from each and every page. If you do this, your retention of the material goes up significantly. Please take the time to do this.